In this video, we'll show you how easily we can slice a relief component in the software so that we can cut it out of a fairly thin piece of material. This will be with the intention of gluing the slices back together again to create one full thickness model. So to get started, we're going to have to create a new instance of a file. So let's go up to File and Close. So first let's go to Create a new file. And then we're going to make sure that our job is a single-sided job, width 24 inches, height 24 inches, thickness 1 inch, units are in inches, Z0 position is off the material surface, the XY datum is in the bottom left. I'm using a very high setting for the modeling resolution as I'm using models in this tutorial, and my material settings are set to Canadian maple. In this case, I'm happy with that. I'll click OK. So in order for us to actually slice a model, we need a model. So let's go up to this tool here for import a component or 3D model, and we're going to choose the Apple edit.v3m file. Let's double click that, and I could press F9 on the keyboard to take it to the center. I can use the align tools here. I could click on this one here to align to material for the center, and it's put the apple in the middle. Now I want to size this up a little bit as well, so let's go to the 3D view and let's go over to the transform objects, and we can set the selected object size. Now in this case, I want the height to be 23 inches, which is just a little bit smaller than my entire workspace. With XY linked, so the width will change appropriately. If I click apply, that will now scale it to be just under the width, or the height, sorry, of my worksheet. So let's close that out for now. And while we're in the 3D view with our model selected, we can also look at changing the thickness of this apple as well. So while we could just right mouse click this, go to component properties, and adjust properties in the menu, you can actually do it down here as well. So if we go for the actual shape height here, in this case, we go for this icon here, we can change this value here from 3.1 to an even 3.75 in this case actually. Hit enter, that will scale the thickness for me, and now we can close out that form as well. But you can see how you can do it dynamically in the 3D view as well. So you can take a look at your apple. Looks pretty good, I'm happy with that. So now let's look at slicing this up. So with our model still selected, let's come over to 3D model tools, the design tab, and we can choose this option here to slice a visible model into individual component slices. So let's click on that and let's have a look at this tool. So the first section at the top here is just a reminder of what we've already set, which is the model thickness of 3.75 inches and the material thickness of 1 inch. And this is also the maximum thickness of the slices that we can actually fit inside this material if we plan on cutting it in this material or on this sheet. Now the next part of the form is a slice thickness. Now you can see here it's set to 1 inch at the moment, and the number of slices it can do with 1 inch thick slices is 4. So the top slice will be 0.75 inches thick, and the next 3 slices will be 1 inch thick, which is taken from here, which is our full model thickness. Now if we choose the from top option, what that does is it means the top slice will instead be 1 inch, the next slice will be 1 inch, the third will be 1 inch, and the fourth will be 0.75 inches. Now this is useful if you want your top slice to be the full thickness that you need for your slice, but in this case I can turn that option off for now, and then with number of slices, this is where you can set the specific number of slices you're looking to achieve, and in this case the slice thickness will be 0.9375 to get 4 slices. And that will be done in 4 evenly sliced parts. So in this case, it will slice it depending on the number here, and it will do so evenly depending on the number here. But in this case, for this demonstration, we're going to use the slice thickness. We're going to go for 1 inch, and we're going to click Set. So now let's have a look at the slice heights. Now this bar over here on the left-hand side represents your entire material thickness. And these horizontal lines here represent the top of each of the slices. The red section here represents the selected slice. The green section here indicates the accumulated thickness of slices above the selected slice. And the grey is a reflection of the accumulated thickness of slices below the selected slice. And you can see it's actually reflected over here in 3D view as well. You can see that the top slice is green, the selected one is red, and the accumulated slices below the selected slice are in grey here. And you can actually select them over here too. So if I click on the one here, for example, that is the bottom slice, so you can see that the red has highlighted the bottom slice and all the ones on top of it have gone green. If we go for the 2 here, that is the one third from top, and then if we go for The 3 here, that is the one that is the second slice, and then the top slice is the one highlighted in green there. You've also got this information down here for the slice thickness in this case, and the top slice thickness. And this is really important to keep a note of, because as you make any adjustments to your model or your slices, this will be reflected here as well. So you can always make any adjustments you need to, and they'll be reflected in this form. And with that in mind, there's actually a couple of different ways you can change your slice thickness. So you can do it from this menu here. So you can increase the thickness here, and you can click apply, and you can see it's changed that. You can also actually, on the 3D view, if I click and double click on an area, you'll notice that the slice actually respects where I've double clicked to, and it makes the slice thickness change depending on where I've double clicked to if I do that again. But you've got to be really careful that you don't click into an area. For example, if I double click into the grey area here, you'll notice on my slice bar it's gone way over and it looks a little bit odd here. But what I can do is I can reset that all by simply just clicking set from my original settings here, and it will go back to my original 4 slices. So do just be careful not to just double click into an area of another slice without meaning to, because you will get this. But you can always reset that, like I said, by clicking set here, and you can undo that change. And similarly, if I click on my model in 3D view, hold shift on the keyboard and scroll with my mouse wheel, I can adjust the thickness of the selected slice, and you'll see it reflected in the form as well. So I can scroll up and down and change the thickness as I need to on 3D view. And this is really helpful when you want to make small adjustments so you can avoid trouble areas. Now, if I wanted to delete a slice, I can just come over to the left here, and I can pick a slice that I don't need and click delete. Similarly, if I want to add a new one in, I can just type in here a value. So I can type in 2.5, for example, and click new, and that adds in that slice there as well. And if I want to start all over again, I can simply hit clear, and I can clear all of the slices from my view. And now while it's clear, what we actually can do is double mouse click on the icon here, and we can actually add in a slice manually. So it's double mouse click, and I can add another one here. And if I want to add one in the middle of this one, I can just simply click in the middle of this section, and I can add another slice in there. Similarly, if I want to get rid of a slice, I can double click on the horizontal line here that represents the top of that slice. I can get rid of it. And I can also choose a slice just by clicking on that horizontal line. So I can add these all in. But for now, I'm happy with the settings I had originally. So I'm going to click on set, and I've got my slices ready to go. Now, in the next section, we have this option here for create boundary vectors. Now, what this does is it automatically generates bounding vectors for every slice, including any areas that are flat as a result of the slice being equal to the material thickness. And in case you forget, we also have the 3D view controls down here as well. So you have a nice little reminder for any of the things that you may forget about. So you've got a nice little reminder here about the slicing form. But for now, what I'm going to do is have a look at slicing the model. I'm going to just quickly tile our views so you can see the 2D view as well. And we're going to slice the model. And what you're going to see is that for each slice, we now have a boundary vector around each of those slices, as well as new bitmap representations of the slices, as you can see on the 2D view. You can also see the actual boundary vectors are on the 3D view as well, so you can click on these as well if you want to view them. Now, if we go over to the component tab, you can see that we've got our individual slices separated out on the component tree, but we've also got our apple as well. If we go to our layers at the top here, we've got our layers with our boundary vector, as well as the actual model component or slice component on that specific layer as well. Now in this case, we don't need the apple anymore, so we can actually just delete that. So we can go to right click and delete, so we can get rid of that. We don't also need the original layer for it, so we can delete that as well. Now let's have a look at these slices. So if we just turn off the other slices for the moment, I'll come up to our layers tab here, and I'm going to turn off the other slices as well. You can see here in the 2D and 3D view, you've got the vector here for the boundary of this slice. So you've got the outer boundary, you've got the inner boundary being the flat area, which represents the top of that slice. And then between the boundaries, we have the 3D area that it will be the part that will be tooled. So when you come to actually make toolpaths, that'll be the 3D component part that will actually be used to, for toolpathing. Now, if we actually select our slice here and right click and choose component, and we go to properties, you can see that it's actually 1 inch, which is the thickness that we set in our form for the slice. You can also see that value over here. If I click on this and we go to transform objects, you can see that the shape height is set to 1 inch here, so I can adjust that if I need to, but in this case I've already got my slice where I need it to be, but you can see that in the 3D view as well. Now if we have a look at the other slices, we know that slice 1, 2 and 3 are all going to be 1 inch because that's what we set it to in the form. So let's turn on slice 4 then, and let's have a look at what slice 4 looks like. And you can see here that slice 4 only has the one boundary vector because it doesn't have a flat area on top. This is the very top slice. This doesn't have a flat section to it. And if we look at the properties of this one, so if you select this slice and then go to component properties, you can see here that it's 0.75 inches thick, which is what we set in the form. And similarly, if I click on the model again to enter transform mode, you can see here with the shape height, it is 0.75 inches there as well. And now let's go turn our slices back on again, and let's turn on our layers for it as well. So you can see currently that the slices take up the majority of my worksheet, and I need to size these down a little bit so I can get them to fit all over my worksheet. So I'm going to left mouse click and select all my vectors as well as my slices. And with the transform handles here, I'm just going to size this down and bring it to a more of an appropriate size for this worksheet. So about there. And I'm just going to drag this into the bottom left hand corner of the worksheet, and then what I'm going to do is select the individual slices along with the boundary vectors for them. So let's click on the slice, hold shift on the keyboard, click on the boundary vector, and let's drag that to an appropriate location. So let's drag that over here, and then what we can do is we can take the next one, so the boundary vector for the next slice and the slice as well by holding shift. Let's drag that one up here, for example, and then what we can do is rotate it using the rotation handle here so we can get best use of our worksheet. And let's drag that over to the right just a little bit. There we go. And then we'll do the same for the next one. So the vectors and the actual slice. Let's bring that one up here, for example, just so we've got a bit of a gap in between each one of these slices. And so far, so good. So I'm happy with that placement at the moment. Now I want to have a 1 inch gap around the edge of my worksheet here and my slices. How do I do that? Let's go to the Design tab, and let's go to this option here to move selected objects. Now what I'm going to do is I'm going to select the vector and the actual slice, and we're going to do an absolute move, and we're going to have an anchor point in the bottom left because we want to be a 1 inch from the bottom left corner here. So we're going to put an X position of 1, Y position of 1, hit apply, and that one I'll place it 1 inch from the bottom left anchor there as an absolute move. So it's 1 inch from the bottom and the left here. And then we'll do the same around the worksheet. So go to the next slice, select the vector, shift, and the actual slice, and we'll go to the top left here. Oh, actually, apologies, this one will be 0.6 and this one will be 23, so we'll hit apply, and then for this one we can just highlight all of those, and then what we can do is go for 12 and 23, hit apply. And this one in the bottom right here, that one doesn't need to, we don't need to worry about that one because that one looks all good so far. So I'm happy with that, so let's close out that form. So next we have to have a think about how we're going to machine this depending on our material, because we're going to have a lot of choices to think about. First of all, we're going to think about how we're going to fix this down to our CNC table. Currently a lot of these components come right down to the bottom of our material there, and there are a few areas that do that. So we could add in some tabs to those areas, but if we did add tabs, that would cause a lot of manual handwork afterwards to remove those parts when we took them off our CNC. We could consider marking the top of the flat areas with a V-bit, and then we could screw these down to our table in the center where our cutter will never get close to, and then we could go ahead and remove them that way. But that still leaves us an issue with the top slice here, where it comes down and it's very thin at the edges there. So we could try double-sided tape, but even that still might not be safe enough after we reconsider all of that. So we need to think about how we're going to reorganize our vectors as well, because we need to make sure that our vectors are organized in such a way that they're doing the right job for the right toolpath. For example, making sure our outer vectors are grouped together for our cutouts, etc. But for right now, I think the best bet is actually going to be to add in the zero plane and give it a slight base height, and then when we go to run our cutout passes, we'll end up having a bit of a lip. And the benefit of that is that the zero plane and its base height will add what we call an onion skin between our parts and our actual waste material, and that will be enough to hold it in place until we get around to cut those out. So let's have a look at doing that, shall we? So let's maximize our 3D view. Come over to the Design tab, go to the 3D Model Tools section and choose the Add a Plane component with zero height covering the model. Now in the background here, you're going to see the zero plane has been added in, but let's go over to our Components tab to have a deeper look. Now you can see at the top here, here's our zero plane, and the current combine mode is set to add. I'm just going to change that to merge, so it merges in. And then what we're going to do is actually have a look at adding in a slight base height to this. So I'm just going to add a base height of 0.03 inches and press space. And what that's actually going to do is, you can see here that the base height has actually climbed up onto a little bit of our component here. So you can see with our top slice over here that the zero plane kind of runs onto it by that base height that we've added. If I turn it on and off, you'll be able to see the difference quite clearly. So you can see here's a slice without the zero plane, and if I put it back on again, you can see how it kind of runs into it very slightly on the edge there. So we'll have this flat edge when we go to cut these out, but when we assemble our parts together, we can easily just sand those out, assuming that our material is easily manipulated like that. So now we're going to have a look at organizing our vectors a little bit, because currently you can see that the vectors are all grouped together because that's how we had it on our slices, but I'm going to actually organize these a little bit better. So first thing I'm going to do is select my vectors, right mouse click and choose ungroup, and I'm going to do the same for the vectors over here, and then I'll finally do the same for the vectors over here. And so what will happen now is that these will all be individual vectors instead of grouped together. And so what this allows us to do now is I can hold shift and I can click on the out vectors only. So the outer vectors is what I want, because these will be the cutout passes. So our profile will be cutting these out, so I can group these all together. So if I just right mouse click and group, so these are now one entire group, and I'll do the same for the flat vectors. So if I go ahead and click the inner vectors here on the inside of our slices, I'll right mouse click and I'll group those together. So that just helps us organize everything for toolpathing, because if we were to run a 3D toolpath to do the flat areas as well as the other areas, that'd be a lot of inefficient machining. There's no need to get a 3D toolpath to do all those flat areas as well as the 3D areas as well. So this will help us with our efficiency for our toolpathing. And now what we're going to do is we're actually going to select our outside vectors here, and they're all grouped together as you can see. And what we're going to do is actually offset these out slightly. So when we do our 3D toolpathing, the finishing cutter will actually go off the edge of our model and end up giving us a nice clean edge all the way around, and get all of our 3D detail that we want around the edges of these parts. So to do that, we'll go back into the design tab and we'll go to this tool here for offset, under offset and layout. Now we're actually going to offset these ones outwards, and we're going to go for a distance of 0.3. We don't need to create sharp offset corners, don't need to do the original, but we will select the new vectors. So let's click on offset, and with these new vectors that are created around the outside, we can right mouse click and we can group these together. And there we are. There's our 3 sets of vectors ready for our tooling. So let's now pop over to the Toolpath tab and let's look at creating some toolpaths. So let's check our material sets. Let's go to the set button here. So in the form here, our thickness is 1 inch. We've gone for the bottom left XY datum. We're actually going to switch our Z0 from material surface to the machine bed. Now the reason is because if we Z0 off our material surface, then if there happened to be a low point where we zeroed off our machine, then that 0.03 of an inch of the zero plane that we added in may get lessened. So we want to keep as much as that as we can. So if we use a machine bed, then we're pretty sure that we're going to get the right measurement, and that should stay pretty consistent all the way through. Now we talked about our model position in our material. Now the reason I'm going to go over this is because earlier, if you recall, I had shrunk down the size of my model here. That's important here to reflect your model thickness in here. So I've put in the 1 inch to make sure that this is the case here. So you can see it's 1 inch in here. But if you ever size down your model for slicing, obviously that affects your thickness for your model, because your original slices would have been done to the thickness of your material. So if you ever size down your slices, you need to reflect that in this menu here. So you can always set the model thickness in here, which would be the thickness of your material, if you recall from earlier. The rapid Z gaps above material, these are safe and sound for my machine, but do double check these for your machine, and the same applies for the Z gap above material. Let's click OK, and let's look into our first toolpath, which is a roughing toolpath. Now if you recall earlier, I said I was going to use a 1/2 inch bore nose, but I've actually decided I'm going to use a 1/4 inch bore nose instead. Now in this case, you can click select here to select your tool, and I'm actually going to change these settings, but not in here. I'm going to close this down. I'm going to click edit, because this will now only change it for this particular toolpath only, rather than in my tool database as a whole. So I want to keep this one at 40% step over, because I can go a little bit more aggressive with a bore nose on a roughing pass. The selected vectors, I'm going to choose the vector for the inside, the flat here, and the outside here. So we're going to machine between these two vectors. So we'll choose selected vectors as a machine limit boundary. Boundary offset 0.25, Leave a little bit of machining allowance for the finishing toolpath to clean up using a Z level strategy. Don't need to worry about ramp plunge moves, but we will call this one 3D roughing, and we'll click on calculate. And there we go, here's our roughing toolpaths ready to go. So let's have a look at what they look like. So let's click on preview selected toolpath, and let's have a look at what these look like. And here we go, so here's the toolpaths ready to go. So let's have a look at what these look like. So let's click on preview selected toolpath and see how they look when they machine. So you can see here where the tool is going between the vectors that we selected to machine in between those areas for our 3D tooling here, and it's just roughing out those areas to try and get the most of the material gone for our finishing toolpath, but of course our finishing toolpath is going to come in and clean up the rest of it. And there we are, that's all finished up. That looks really good. So let's now have a look at our finishing toolpath. So let's close out our preview, go back into the toolpath form, go 3D finishing toolpath, and we're going to remove the 1/8 inch bore nose. Going to use a 1/4 inch bore nose again, but this time I'm not going to adjust any settings. This is set up for a finishing toolpath. So let's click on select. Again, we're going to use selected vectors. We're going to go between these two vectors again. In this time, we're going to use a boundary offset. I'm going to use the offset strategy. Call this one 3D finish. Click calculate. And we'll have a look at what this toolpath looks like in just a moment. So let's preview this selected toolpath. And you can see here now that this is cleaning up all the areas where the roughing got to. So the finishing path is now going over the areas the roughing did not, and it's cleaning up those areas for us. And you can see it's getting a really nice, clean result out of those slices. And that looks really good. So next thing we can look at now is our profile toolpath. So let's just close out of our preview here, come up to the profile toolpath, and this time we're going to select the vector in between the vectors that we had selected, which is these vectors here, so the vectors in between the outside and the inside flat ones. And this time we're going to go for a Z depth of the full thickness, which is Z equals, which is 1. We're going to choose a 1/4 inch ball nose this time, and click on select. I'm going to cut outside on the vector here, so outside of this vector. Don't need to worry about separate last pass, but I am going to add tabs to this one, and the tabs are going to be a length of 3 inches, and the thickness is actually going to be 0.03, which is, if you recall, the base height we added to our 0 plane. And we can go into edit tabs, and we can tile our views here, and we can look at placing our tabs where we want them. So I can just click around these areas and place the tabs where I need them. So I'll pop a couple in here, just so when I come to remove this later, this is nice and secure, so I can take it off nice and easy and safely. And we'll just pop some of these in over here. And there we are. I'm going to close that out. I'm going to call this one profile. Click on calculate. And then we'll maximize our 3D view. And we'll have a look at our profile toolpath. And you can see how the tool's going around and cutting down there. And if I zoom in, you can see where our tabs are. But you can see there's a little bit of material left over, and that's from our 0 plane. So that's where we added in that base height for the 0 plane. So it leaves a little bit of material left over so that we can safely remove this without too much effort. So let's just pop that back into view. And at this stage you can look at saving off your toolpaths, and you can refer to the toolpath saving guide on how to do that. But for now, that concludes our tutorial on how to use a slicing guide. I hope it helps you with your models and your slicing needs, and hopefully to help you make the most of your worksheet with your models. Look forward to seeing you in the next video.